Diagram shows the apparatus used to electrolyze a dilute sulfuric acid. Complete the box to show the role of the platinum. Or what is the role of the platinum? So these are the electrodes. Give one observation made during this electrolysis. When you are passing a current, during this electrolysis, what you will observe? You have a sulfuric acid. So sulfuric acid means hydrogen ion is there. Sulfate ions, hydroxide ions are there as well. So hydrogen will move towards the cathode, so you will see bubbles. And when hydroxide will move towards the anode, that will also give oxygen gas, so we will see bubbles. So bubbles seen, one observation during this electrolysis, or what we will observe. So we'll see bubbles, phase, or effervescence. So at this part, we will see bubbles, fizz, or effervescence. Then the next part we have to compare. So compare the volumes of oxygen and hydrogen produced. So when you compare the volume from this figure, what you can say when you're comparing the two gases? So more hydrogen than oxygen, and the second mark, because it's of 2 marks, so 1 mark is for mentioning like greater amount of hydrogen, and the second mark is for comparison, like it is approximately twice. So answer for this question, volume of hydrogen produced is more than oxygen, and it is approximately twice of oxygen. Which substance break down to form these gases? Like we are getting a hydrogen gas and we are getting oxygen gas. So which substance decompose to give these gases, oxygen and hydrogen? So water is the correct answer. Why water is the correct answer? Because hydrogen and hydroxide, hydrogen is ion is responsible for formation of hydrogen gas, and hydroxide is responsible for oxygen. So which substance can give these gases, hydrogen and hydroxide ion? And when you have H and OH, what it result? It will result in a formation of H2O. Give one test to distinguish between oxygen and hydrogen. So one common test you have to mention. You learned a separate test. For hydrogen, it is a lighted splint, it pops, and for oxygen, it is a glowing split reline. So what will be the effect? Like if you use a lighted splint, it will have no effect on oxygen, but it will pop with hydrogen. But if we use a glowing splint, it will relight with oxygen, but no effect with hydrogen. So any one of them you can mention. If you mention a lighted splint, with oxygen, the lighted splint, or it will pops for hydrogen. But other way around, if you want to write a glowing splint, With oxygen, it will relight and no, the glowing splint is not does not have effect for, so there is no effect with hydrogen. Glowing splint is a test for oxygen, and lighted splint is a test for hydrogen. So any one of them you have to mention. Question 2. A student investigated what happened when a dilute nitric acid reacted with aqueous solution of two different alkalis, solution N and O. So two experiments were carried out. Experiment 1, a measuring cylinder used to pour a 50 cm cube of solution N into a polystyrene cup. The initial temperature of a solution was measured. A burette is filled with nitric acid to 0.0 mark. 5 cm cube of nitric acid is added in a polystyrene cup and solution is stirred and the maximum temperature is measured. A further 5 centimeter cube of nitric acid was added to a polystyrene cup and the solution is stirred and the maximum temperature of a solution was measured. The student continued to add 5 cm cube portion of nitric acid to a polystyrene cup until the total volume is 40 cm cube. After each addition, the solution was stirred and the maximum temperature is measured. Use the thermometer diagram to record the maximum temperatures in the table. You can use a screen annotation to complete the values for maximum temperature. What are the maximum temperatures? Yeah, the first one is 22. Second one, 24. The third one, 26. 28, 30, 31. After 31, this one, 30, 29, and then 28. So these are the maximum temperatures. Then experiment 2 was repeated using a solution Q instead of solution N. What are the temperature readings? The maximum temperature. The first one 20, the second 21, third one 22, then fourth one 23, 24, 25, 24, 23, and then 22. So these are the temperature readings. Now what we have to do, plot the results of experiment 1 and experiment 1 and 2 on the grid and draw two smooth line graphs. When they use the term smooth line graphs, you don't have to use a ruler or a scale. Just you have to draw a freehand. Just join the points with each other. So the values for the first experiment, the values, I will write it here for the two experiments, because the maximum temperature and the volume of the solution. So the first value was 22, then it was 24, 26, 28, 30, 31, 29, and 28. And then the second one, it started with 20, 21, 22, 24, 22, 23, 24, then 25 was there, then 23, 20 was there, 21, 22, 23, 24, 25, then 24, then 23, and then 22. And this was 22, 24, 26, 28, 30, 31. Again, 30 will be there, 29 and 28. So on the grid, we have to sketch a graph. As you can see, each value is for the volume 0, 5, 10. So for first experiment, when it was 0, the initial temperature was 22. Each box is representing, two boxes equals to 1. So 21, this one is 21 and 22. So I have 22 here. Then 24. So this is 24. Then 26, 26, 28. So this is 29 and 28. Then 30. 31. 29. And then 28. So 26. This one is 26, 27, and 28. So what we have to do, we have to draw a freehand graph, the smooth line graph. So we have to just join these points. This is for the first experiment. You should label as well, experiment 1. And the second one is for experiment 2. The experiment 2, the values, the first one is 20. And then 21 is there. Then 22 is there. 23. 24. 25. And then 24 again. And then 23. And 22. For this one, the graph will be like this. This is experiment 2. Just join the points. So and label them experiment 1 as well as experiment 2. So you can see experiment 1 shows a greater change or rise in temperature as compared to experiment 2. The next part, use your graph to estimate the maximum temperature of a solution when 13 cm cube of nitric acid is added to 50 cm cube of solution N in experiment 1. So this is a graph for us when 13 cm cube is added. So what we will do, and you should clearly show on the grid. So you have to draw these lines like this is 11, 12. So here is 14 and 13. So we'll draw a line from 13 and find the temperature. So that is 26, 27. So the answer for this part is 27. The next part, name a suitable indicator that could be used in experiment 1. We are reacting acid because in the beginning, as you check the reactants here, a nitric acid is there, which is added to a solution of alkali. So what indicator can be used for this purpose? A suitable indicator you can mention. So methyl orange you can mention, phenolphthalein you can mention litmus. The next part, solution N and O were same concentration. So solution N and O having a same concentration, in which experiment is the temperature change greater, and explain why the temperature change is greater. So if two solutions have same concentrations, because what we did, we took polystyrene cup, we take equal concentration of N and O, and from the burette we are adding an acid, nitric acid. Solution N and O have the same concentration, means same number of the particles in a unit volume. But when we observe experiment 1, we find that experiment 1 shows a greater change in temperature as compared to experiment 2 from the results. What could be the reason for that? A possible reason, what could be the reason if you are adding an equal amount of nitric acid, 5 cm cube every time, and you observe a temperature change, but when you are adding nitric acid to experiment 1, you observe a greater change in temperature compared to experiment 2. So what could be the reason why the two of them are showing a different temperature change? You cannot mention different concentration. Already they mentioned they have the same concentration. So if they have the same concentration, means they have the equal number of particles in a unit volume. But experiment 1 shows a greater change in temperature. So the possible reason is because acid, here we are using a nitric acid and alkalis. So experiment 1 shows a greater change in temperature, and reason is that the solution N is stronger acid, stronger alkali, or having a higher, no, not about different temperature change. When you compare a temperature change from initial value to the final value, the maximum temperature with solution N is still higher. The difference is higher as compared to that of O. So reason is that solution N is a stronger alkali. That is why it show a greater change in temperature as compared to O. How would the result differ in experiment 1 if 100 cm cube of solution N is used? We are using more volume but with the same concentration. So what will happen to the temperature change? It will, if you use a larger volume, instead, no, we are using a same concentration but larger volume, because this 100 cm cube, it's not about concentration. We did not change the concentration. What we are doing, how would the result will differ if experiment 1, in experiment 1, if 100 cm cube of solution N is used? Here we use 50 cm cube. So what will be the result? The result, the temperature change will be half. So what they mean here, like you have two solutions. One is 50 cm cube. About the product, because we are measuring a temperature, so we can mention things related to a temperature. We are not measuring the volume of the gas given off. So you have 50 cm cube of solution N. Now what you are doing, you are using 100 cm cube of solution N. So this 100 cm cube required more energy to show a change in temperature as compared to 50 cm cube, because what happened, the reactant particles are reacting with each other and it is releasing energy. That energy is absorbed by the water. Here you have 50 cm cube of water. Aqueous solution means like the volume of a solution refers to volume of the water. So 50 cm cube of water required a smaller amount of energy to show a change in temperature. 100 cm cube of solution required more energy to show a change in the temperature. That's why the temperature change will be smaller. If they say they double the concentration or increase the concentration, then you will mention that the temperature change will also increase. But when they are mentioning in the question that the volume is double for a solution, so the temperature change will be half, the relation between the volume of the solution and temperature change are inverse. If I use a large volume, I need greater amount of heat energy. That's why the temperature change will decrease. Is it clear? Yeah, the question says result. So what is the result here? You're measuring a temperature. So you're only observing a temperature. That is your result of the reaction. You're not measuring a volume of a gas. So you have to refer your answer with reference to what you're measuring. You're measuring a temperature. So you're observing your result of this reaction is a temperature change. Suggest why a polystyrene cup was used in these experiments, not a copper cup. What could be a reason polystyrene is used? So polystyrene is insulator or copper is a conductor. So copper will transfer. We don't want the heat to transfer. So polystyrene is an insulator or bad conductor of heat. So that otherwise when the reaction occur, if we use a copper cup, copper can take energy from the solution and copper will transfer that energy to the surrounding. So reason why polystyrene cup is used, because it is insulator, does not allow heat to escape or reduce the heat loss. State one source of error in the experiment and suggest an improvement to reduce this source of error. So here, because the temperature or heat, you're measuring a temperature change, and that is by the change in the heat of the solution. So if you are using a polystyrene cup, it might lose heat energy to the surrounding from the top, because you're not covering the top. So source of error, heat loss to surrounding. And how you can improve that, you can improve by putting a lid or a cover. Or second thing, you can also mention source of error is the use of measuring cylinder, because you are measuring a volume of a solution by using a measuring cylinder, so you should replace by a burette or measure the volume by a burette, which will be more accurate. Any one of them you have to either heat or either related to measuring cylinder. How the volume and temperature are inversely proportional. Burette can measure, smallest value with burette can measure is 0.1 cm cube, and maximum it can measure to 50 cm cube. But for pipette, it's a fixed volume. Either you can have a 25 cm cube or you can have 50 cm cube. Normally 25 cm cube are there in the lab. So pipette can only measure a fixed volume of 25, but burette can measure a smallest value of 0.1 till 50 cm cube. How the volume of the solution and temperature change are related? If you have two solutions, one is 50 cm cube, another one is 100 cm cube. These are alkaline solution, same alkaline solution but different volume. Now what we are doing, every time if you read the question, every time we are adding 5 cm cube of acid. So when I'm adding a 5 cm cube of acid, and here also I'm adding a 5 cm cube of acid, so when acid is reacting with an alkali, it is releasing the energy. Example, due to the reaction, it released 2 joules of energy. So it will release 2 joules here and same 2 joules here because we are adding a 5 cm cube, same amount of acid from the burette. So it released 2 joules of energy in the second reaction. Because you have small number of the particles of water, so most of the energy taken by the water, that's why the temperature change for this small quantity of water will be greater. But that 2 joule which is released due to the reaction is distributed between the particles, more particles of water. That is why the temperature change will be smaller. Like if this is causing a 2 degree or say 12 degree 10-degree change in temperature in A, so this will cause maybe 7-degree or 5-degree change in temperature. Is it clear? Yes, Afif?
So the second container has like more mass, right? Can I say that?
Yeah, more mass. But when we say volume of a solution refers to the amount of water present in it. Aqueous solutions. Like if I say I have 100 cm cube of aqueous solution, it means I have 100 cm cube of water. So
So like, can I say that the second container has a higher specific heat capacity?
specific heat capacity is constant. Heat capacity you can say more. Specific heat capacity is constant for materials. Heat capacity is higher. Yes.
Okay, sir. Thank you, sir. It's clear now. Thank you.
The next part, solid P is aluminum salt, was analyzed. Test on solid P and some of the observations are shown. Test on solid P. Test number 1. Solid P was divided into 3 portions. They already mentioned it is an aluminum salt. Solid P was divided and the first portion was heated. Condensation formed on the side of the test tube. What this gives an idea about the type of the salt. If you are heating a salt or you are heating a, what you observe,
Hydrated salt.
hydrated salt. It contains a water of crystallization, so it's a hydrated salt. Any gas given off tested with a cobalt chloride. Actually, cobalt chloride paper is a test for water. So this confirmed that the vapors, the gas which was there is water vapors, are water vapors. What does test 1 tell you about the solid P? So it gives an idea. This is hydrated salt or contain water of crystallization. Test 2, a flame test was carried out on the second portion of solid P. What is the observation of a flame test? With aluminium, you learned only for sodium, potassium, lithium, and copper. So flame test for any other, if it is there, what you will write? You will write no visible change. It will give a characteristic energy, but that is not in a visible range. That's why we do not observe specific color. So no visible change or no visible flame color. Test on solution P. Distilled water was added to rest of solid P in a test tube and shaken to dissolve. Solution was divided into 4 equal portions. The following tests were carried out. Test 3. Several drops of sodium hydroxide was added to a first portion. If we have aluminum salt and we add an excess of sodium hydroxide, what is the observation? First, what will happen? Because when even they say excess is directly added, it does not mean that you have to mention first what happened to 5 drops and then what happened to excess. So first it will form white precipitate and in excess does not
Sir,
dissolve.
this is from the test. Yes.
Test for the ions, yes. White PPT does not dissolve in excess of sodium hydroxide. Test 4, several drops of aqueous ammonia were added. Then excess of aqueous ammonia is added. What is the observation? The previous
White
one,
precipitate and doesn't dissolve.
the previous one was white precipitate because it was sodium hydroxide. So white precipitate dissolve in excess. With sodium hydroxide it dissolve, and with aqueous ammonia it does not dissolve. So here the answer, when we add sodium hydroxide, it should be white precipitate first and then dissolve in excess with sodium hydroxide. And for aqueous ammonia, it will be white precipitate does not dissolve in excess. Then two further tests were carried out and the following observations made. Test 5, dilute nitric acid and aqueous silver nitrate, no visible change. So this is a test for halide. It means there is no chloride, bromide or iodide. These ions are absent, that's why there is no visible change. Dilute nitric acid followed by barium nitrate. So this is a test for sulfate ion, white precipitate. What does test 5 tell you about solid P? What does test 5
That it's
indicate?
not a halide.
So it does
That
not
it's
contain
not
halide.
halide.
So no halide ion is there. And identify solid P. It is aluminum that is mentioned in the beginning, and because it
Yeah,
is the second test 6 is sulfate, so this is aluminum sulfate.
but it's
So
mentioned, Mr. already.
aluminum is not giving you mark, sulfate will give you mark, and it's of 1 mark for
Okay.
mentioning. When they say identifies, you have to write a full name. If they say identify the negative ion, then it will be sulfate. Describe the appearance group 1, 2, 3. If they are solid, that will be white solid. If there was a transition metal, then it will be a color. If it was a solution, the same question was there. Describe the appearance of solution of P, then it will be colorless. But solid, it will be white solid. Then the last part is the planning of experiment. This we already discussed, but I will quickly go through. So agri-lime, which is a mixture of calcium carbonate and calcium oxide. Farmers use agri-lime on the field to neutralize the acidity. Plan an investigation to find which of the two agri-lime Q and R neutralizes some more acid. So how you can plan this? What you will do? You will take equal amount of, or take 2 containers filled with equal amount and concentration of acid. Add indicator, then add agri-lime Q and agri-lime R and measure the amount of agri-lime added. The one which we need a small quantity of agri-lime, it is more effective. That is one way. Or what you can do, you can measure the mass of, you take equal masses of the two agree-lime, add indicator, add acid from the burette until indicators show a color change. So the one which required a greater volume of acid for neutralization or a color change, that is more effective or a better agree-lime, or that is better for treatment of acidic soil. Is it clear, this experiment? Any doubt in this? So I'll share another link and I will discuss paper 2.